To find our limit as x approaches infinity, our rule states that the limit as x approaches infinity of f of x is equal to c, and our limit as x approaches c of f of x is equal to infinity. Now let's always keep in mind that anytime we see the limit of 1 over x as x approaches infinity, it's always equal to 0. So let's bring up the fact about degrees. So for instance, let's say if our degree in our numerator is the same amount as the degrees in the denominator, we know that our answer is going to be the leading coefficient in our numerator and our leading coefficient in our denominator. So say if our numerator is less than the degrees in our denominator, our answer is always going to be equal to 0. And vice versa, we have our numerator degree is greater than our degrees in our denominator. So we know that our answer is going to be equal to infinity. So for our example, we have the limit of 2x squared plus 5x plus 5 all over 3x squared over minus 2 as x approaches infinity. So we can then rewrite this, or let's go back to our problem. So we know based on degrees that our leading coefficient or our leading degrees, in our numerator and denominator are the same. So we know that our answer is going to be the leading coefficient in the numerator and the leading coefficient in our denominator, which is 2/3. So let's work this out and see how we get there. So we can then put everything over x squared, and now we have 2 limit of x squared over x squared plus 5 limit of x over x squared plus the limit of 5 over x squared all over our denominator, which is the 3 limit of x squared over x squared minus the limit of 2 over x squared. So let's go back to what we always should remember. Our limit of 1 over x as x approaches infinity is always 0. So now we know that going by our rule, we can state that 2 plus 5 times 0 plus 5 times 0, which is 0 plus 0, leaving us 2 plus 0, which is 2, and our 3 minus 2 times 0, 3 minus 0, giving us 3. So now we know that as x approaches infinity, our answer is 2/3.